Hi, I'm Michael, and in this one, I'll be creating a Python web scraper that fetches the menu from my favorite brewery. Then, I'll create a cloud Python microservice that detects if the menu has changed, and if it has, it'll send me a text message. This video assumes that you have some exposure to a programming language such as Python, and to a cloud environment such as AWS. However, if you do not, I'll be trying to break things down so you can kind of see that it's not too difficult, and it might be something that you're interested in learning in the future. So let's get started. For this one, we will need two modules to begin with at least. The first one is the request module, and the second is the beautiful soup for module. So Python modules are just files containing code written by others. We can leverage them to save us a lot of time, and that's what we're going to do in this one. So request is an HTTP library for Python. It's built for humans and machines. It allows us to send HTTP requests. Essentially, what we're going to use it for is to do a GET request to pull the contents of my favorite pub's beer list, and they have a menu portion on their website, so that's what we're going to pull from. Okay, so we'll begin in the main method here in the Python file. This is in my example1.py file. I'll be putting all of these on my website, so if you're looking for these, feel free to check it out there. I'll also have links in the description below. We're going to be scraping the menu from my favorite pub's website. So they have a little portion on their website here that has all the beers listed out. So I'll go there and we can see that firsthand. And bam, here we are. So I want to parse through this website and I want to grab all of the names. I want to grab the descriptions and the price. And I want to do that using Python. So here I'll save the URL to the menu as a string, and I'll call it URL. We'll then perform a GET request on that URL, meaning we're going to fetch all of the content of that website, and we're going to store it in the result variable here. So if I do a print statement here, and I run this, you'll see down here, we're going to get a lot of gibberish. This is HTML, JavaScript, maybe some CSS, just a lot of stuff in here that makes up this website. And so when you go to this website in your browser, whether it's Chrome or Safari or whatever, it knows how to interpret all of that HTML and code and make it look nice for you. So that's great, but it doesn't really help us, right? Because we want to get the names, the description, and the price, and we don't want all the other gibberish. That's where the beautiful soup module comes into play. So straight from their website, Beautiful Soup is a Python library for pulling data out of HTML and XML files, which is exactly what we're looking for. We just got the HTML file, and now we want to pull out the data from it. We want to extract stuff from it. So let's do that. So we import our Beautiful Soup module, and then we create a Beautiful Soup object with two parameters here. So we instantiate it with two parameters, which is the content that we just pulled. This is the brew list content, the website, all of this gibberish down here. And we declare that it is a HTML parse. So it's not XML, we're parsing through HTML here. And we store that object as an object called soup. So if I print out soup.prettify, we can see the difference here. So let's do that. Okay. So see how it's a little more formatted, a little more readable. That's great, we're getting somewhere. So the next step would be to use Beautiful Soup to parse through this data to get the text and the information we're looking for. And so if we go over to the website here of our beer list, and we right click and we hit inspect, we can see here's all of the code that we pulled when we did our request. But we want certain things. And so when I look through all of this code on the menu board here, on the menu website, we can see that the overall encapsulating class is a menu board. Class menu board, and it's a div. And you'll see there's a pretty version, but now when we look for just the divs with that specific class name, so as you can see, we got the menu, it's looking better, but there's a lot of extra stuff in here still, and we just want the names, the descriptions, and the price. And you can see the class names in here that we're looking for. So the title, we heavy, class, there's content in there. And so that's what we're going to parse for. We're going to scrape further. And that's where the name kind of comes into place. We're scraping through the web here for the content. So over in the code you can see the class name here that contains our titles is called BTBB column content, and it's a div. So let's store our previous web scrape and then scrape that even further, finding all divs with this class item content, and store that into content, and then we will print that out and see what that looks like here. So as you can see in here, content here is an array that contains all of the content that was encapsulated by the div with the class name item content. Down here we can see that there are a few classes: BTBB menu item title, title price, and I believe there is title description as well. Yep, here we are. So we want to iterate through each item in that array, parsing even further for the div with a class name description, a div with the class name price, and title. We want to get the text, meaning we want to remove the HTML, and then I want to strip it, meaning I want to remove any white space. Then I'm going to store the content of all of this into a variable called item description, item price, and item title accordingly. So let's do that, and we'll print this out here. And you'll see there it is. So next, let's go over to example 2. And again, I'll be putting all the code on my website. So if you're looking for any of these examples, feel free to check it out at hiimichael.com. I'll also be putting more links in the description below to guide you along and help you. The next thing I want to do, now that we have the description, the price, and the title, is I want to store all of these in a database, specifically a cloud database. So if the database is 3 columns, one would be the description, one would be the price, and one would be the title. And then every beer would simply be a row. For a database, I'll be using DynamoDB. For this, we'll need another Python module. AWS has one called Bado3. Bado3 is an AWS SDK for Python. It allows us to create, configure, manage AWS resources. The database I'll be using is Amazon DynamoDB, and I'll have links to all of this documentation in the description below. Amazon DynamoDB is a fully managed NoSQL database. That's why I'm using it here. It's fully managed. I don't have to create any Ubuntu instance in the cloud to host a MySQL server or anything like that. I don't have to maintain this. There's not a lot of data here either, so this is going to be quick and simple. There's a lot of great DynamoDB documentation, so you can see here that we can create a table, we can put items into it, which is essentially all we need to do here. So in our Python code here, I use the Bado3 module to create a DynamoDB resource. I do this using some secret access keys here. These are generated on the IAM page in AWS, and it allows us to access certain resources in AWS. Remember, AWS is a cloud platform, so it needs a way of knowing like who is trying to access AWS here, and this is how we do it. It also needs a region name, which is the region the resources are in. So what exactly are access keys? Access keys in cloud computing are long-term credentials for an IAM user that allow us to sign programmatic requests, which is exactly what we're looking for here. So what is an IAM user, or IAM user? It stands for AWS Identity and Access Management, and this is how we are going to securely access our AWS resources. This allows us to connect to the cloud and put stuff in the database up in the cloud, to send text messages, to do all of that. So the first step is to create a AWS account or a cloud computing account, and then the second step would be to create a user with the correct privileges and then generate some keys so we can use that user to run our code with those privileges. So in AWS, I'm going to look for the IAM service here. It is important to note that the UI changes a lot, so it's just the concept here that you really need to understand. You want to look for the users, and you want to create a new user, so you're going to see something called Add Users here. You're going to click on Add Users, and we're going to create a new user. You can name your user whatever you want here. We can just call ours Web Scraper. Then make sure the access key programmatic access is checked. That's why we're doing this. And go next to permissions, attach existing policies directly, and this is when we're giving it the privilege to do things. So we want our user to have access to our DynamoDB database, the ability to send text messages, and that is it, I think. Yeah, that would be good. So we're going to look for DynamoDB, and there it is, DynamoDB full access. And then we're going to look for simple notification services, which I believe is just SNS, and do Amazon SNS full access, which is great. Tags if you want to. I'm going to skip this and hit review, and I'm going to create the user. Here you can see we have our access key and our secret access key. So you can download the CSV here, and then here are the values that you are looking for. So back in the code, you can replace these with those strings, or you can go into the test keys file and add those strings there. You can see here we have a variable table name, which is a string called beer list. So let's create that table called beer list. Back in AWS, we're going to search for DynamoDB, which is that managed NoSQL database. So here you can see we're in US East 2. I have this table already created in US East 1, however I'm going to do it in 2 here just so you can see. The UI may look different, but just look for Create Table and enter in the table name. Next we need a partition key. A partition key is used as the table's primary key. So this is essentially like an ID. If you're used to a relational database or something like that, it's used to retrieve items from your table. So since each of the beer names are unique, I think using something called name would be perfectly sufficient. And then I'm just going to create the table. And I actually have this created in US East 1. However, that brings me to a second thing here. You need to take into consideration here the region. And this is that last parameter in our DynamoDB object. And that's where you find that, the region name. This is the region where you create your table. Okay, so here we are in DynamoDB in the console. And we can explore our table items, however, there shouldn't be any in here. So here we are back in the code, and we use the Botto3 module to create a AWS resource connected up to DynamoDB. We use our access key IDs, which we just generated using the IAM service. And then here is that region that our DynamoDB table was created in. We then use our new DynamoDB object to access the table by the name stored in variable table name, which is beer list, which we just created. And we store that in table. I have a couple sets here. Now I'm using sets because we can't have duplicates in a set, and I won't have duplicate beer names here, so I thought that would be a good data structure for that. This is the code that we did already, where we get the item description, the item price, and the item title from the website. We scrape that. I then store the title, which is the beer name, in a set. So I'm keeping track of the current beer names. Now this is where we put the item in the database itself. So I'm going to uncomment this here, and you're going to see that we have our table, our DynamoDB table, and we are putting an item, and this is all imported from the Bot03 module. I didn't write this put item, we're just leveraging someone else's code here, written by AWS, the people over there. And we are putting an item into our DynamoDB database. Here's our name, which is our primary key, and that will be the title, the beer name. We will have one column, which will be the price, and another column, which will be the description. And so we're going to put a row in the DynamoDB table for each beer, for each menu item. So now let's run the code here and see what happens. We'll see when we run example 2, there will be a whole bunch of successful put items. So when we go over to the DynamoDB and refresh, we should see a whole bunch of beers, their descriptions and their prices now stored successfully. Pretty neat. Now that we have the current beer list stored in DynamoDB, we can read the menu here back from the database doing a scan. Not super efficient, but it works. And I say it's not super efficient because it's going to read the whole database. However, the menu is not super big. So in this case, it is perfectly fine. And I can read through the items, printing the name, the price, and the description. So let's run that. And there we go. Now here are all of the beers pulled from the DynamoDB database. So what do we do from here? Well, remember how we have two sets. We can store the current menu, the one that we just web scraped off, into one set, all of the names of the beers. Then we can pull the beer from the database, and we can do a difference on those sets. So that means if we scrape the beer menu from the current website, and we see that there's one name on that menu that's not in the database, that means it's a new beer. There has been a beer added. However, if we pull all the beers from the database, and we see that there's a beer in the database that's no longer in the current web scraped list, that means that that beer has been removed. So I'm going to uncomment this bit of code here, and what this does is it takes the difference between two sets. The saved menu, the beers we pulled from the database, and the current menu, the beers we just web scraped. It stores the length of that into an integer, and that integer represents the beers removed count, the number of beers we have removed. And then I can print those beers by doing the difference, and this returns a set of the difference, which would be a set containing the names of the beers that no longer are on the menu. Vice versa, we have this bit of code here, which does the difference of the current menu and the saved menu, meaning that returns the items that only exist in the current menu, indicating that a beverage has been added. Okay, so here is the current menu, the one we web scraped, and the saved menu, the one from the database. And we return the length, meaning here are the beers added. I then take the difference of those sets, and the ones that exist in that set would be beers added because they are no longer, they don't show up in the database. So let's play around with this for a second. If I were to go into the database here and pick a few of these and delete them just by hand. Yes, I want to delete these. And then I run this code. That would be like saying that there are some beers in the current menu that do not exist in the database because we just deleted them from the database. So that would be like saying they're new. They're brand new beers because they are currently in the web scraped list and they don't exist in the database. So they should show up here in this difference. So let's run that and see. And you'll see here, no beers have been removed, but 3 beers have been added, and those are the ones that we just added. So now that we have the ability to tell whether or not a menu item has been added or removed, what can we do with that? Well, we can send a text message. And that's kind of the point behind this whole thing. And the last remaining step before finishing this up in AWS is how do we send a text message from Python? And we can do that using AWS SNS, or Simple Notification Service. And we already gave our user the privilege to do that. So it's really just a matter of looking at some of the documentation code. So first what we need to do is create a client object. And this is similar to what we did with our DynamoDB resource. We use Botto3 and we create our client object for sending text messages with the parameter SNS, the same access keys, and the region. We do not need to do anything prior in AWS because it will create everything here in the code. So how this works is we create our client object and then we subscribe to a topic resource. This resource has a name that we create, and I'm going to call it beer list. So the way this works is that you could have a whole series of phone numbers here, a whole list, and they can all be subscribed to a single topic. When I then forward a message onto that topic, the message will be forwarded to all the numbers. And that's how that kind of works here, only there's just one number and that's mine. And if the topic doesn't exist, this will create it for you. And that's kind of nice, so you don't have to do anything in AWS here prior. I start and I create our message string, and I then check to see, have any menu items been removed? And if so, I add that string to the beer me up Scotty string after some new line characters, and I say, hey, this is how many beers have been removed. I add a new line character to that message, and then I check to see, have any menu items been added? And if so, I do the same thing. I add those menu items. And I do it with new lines here so that it's like a list. I then delete the old list and I update the table. And this line right here is where the magic happens. This will send the message to the topic, and then my number is subscribed to that topic, so I should receive it. So to test here, I'll go and I'll delete some beers from the database and I'll run this code, and I should see the text messages flood in here. So let's just select a few random beers here. And so we're going to go up here and delete these for the test. And so when I go back and run the code, you'll see those are the beers that we just removed, and it is acting like those are new beers. And I should get the text message that 5 menu items have been added. And now if we want to test again, we refresh and we can see there are 24 items. Now we can go through and I'll delete, let's say, 4, and I'll rerun the code. 4 items have been added, and we get our text message, 4 items have been added. Great. So the remaining step here is to take this code and to put it up in the cloud and to have it routinely fire. To do this, it will be entirely serverless, and we're going to be using AWS Lambda. AWS Lambda is serverless event-driven, and it allows us to run this little bit of code routinely. So in Lambda, we're going to create a function. Now your function name could be whatever you want. Again, I'm just going to call it Beer Me Up Scotty. Now we're using Python, and I'm going to create. So you may have noticed I switched regions here. I have already done all this, so I just switched over to my other region. And the next step is to get all of that code that we just created up into Lambda. Back in the code, we're going to import one more module. This is the JSON module, and this is because Lambda functions expect a return of a JSON. We're going to make just a few changes here. Instead of a main function, Lambda expects a function by the name of Lambda handler, and you can tweak this, but by default this is what it is. There are two parameters, I won't get into that here. Then it also expects a return, and that's why we imported that JSON here. And you can tweak this to be whatever you want. If you want this to be a different string, say the count of beers or something like that, or maybe the message, you can definitely do that. You want to rename the file to lambda_function.py. And all of this will be on my website, so don't worry about it. So to recap, we switched out the main with the function lambda handler. We returned a JSON, and we renamed the whole file to lambda_function.py. Take that file and drop it into a folder called My Deployment Package. An important thing to remember is that we had to import a couple modules here. AWS, the cloud environment, is not going to know what those modules are, so we're going to have to include those. AWS actually has some great documentation which shows just this, so again, I've said it a few times, but I'll include this in the description below. So let's go ahead and install those packages into that same directory, which now has our one file. And that's going to look a little bit like this. So I'm using Python 3 to install the requests package into the current directory, and I'm currently in the My Deployment package. So on a terminal, you have to use cd and c into this folder, which has your Lambda function. So let's run that. And you'll see now the dependencies that we need are there for requests, and we will do the same for BS4. And now those are in there as well. Okay, so then back in the documentation here, you can see the final step is to turn that directory into a zip file. You can do this in whatever way you want. You just want all of those files to be immediately under that directory. So if you have 7-zip, you can click on that folder and use that. You can use the zip command, whatever you want to do. Then back in AWS Lambda, look for the upload section here, the upload from, and select zip file. Here, this will allow you to select the zip file you just created, which you can save and upload. AWS Lambda is an event-driven service, so I need something to drive this script to tell it to function over and over. And we're going to use EventBridge to do that, and I'm going to do it on a routine schedule. So let's do that next. So in Lambda, you want to add a trigger here, then look for CloudWatch events, create a new rule, give that rule a name, let's call it business hours. You can give it a description if you'd like. And we're going to do a schedule pattern. Now this follows Cron expressions. So you can see I just pulled it from one of these here. And so 6 p.m. Monday through Friday, 8 a.m. on the first day of the month, there's so many here. Say you did 6 p.m. Monday through Friday. At 6 p.m. Monday through Friday, this script, Beer Me Up Scotty, will fire. And that would be completely sufficient for checking menu changes and sending out a text message. This same code could easily be refactored, say to search for video game consoles on GameStop, Target, Best Buy, other websites like that. Thank you all for watching. I appreciate you guys taking the time to watch this. I hope you learned something, and yeah, have a good one out there. Bye.